Section 9.3, Graphing Quadratic Functions. So, a quadratic function is a function that follows the form y equals ax squared plus bx plus c, where a, b, and c would be numbers. And what this does is something very different than the equations we're used to. Up until now, probably the main graph that you've looked at is the graph of a line, which is y equals mx plus b in slope-intercept form. And so this time now, when we start looking at quadratic functions, we're looking at things that have x squareds. And so we have this form that we call standard form. And the things that make it standard form, well, there's really just one, is the order that we put these in, that we put x squared first and then x, and then if we have a number that doesn't have an x or an x squared, it goes last. Now, if I wanted to understand what this would look like, we could just plug in some random numbers. Maybe this is the kind of function that we want to graph, and so a would be 3, b would be 5, and c would be 1. Well, what we want to do before we get too carried away is let's start with a really simple quadratic function. It's actually the simplest one we can look at, which is y equals x squared. So if y equals x squared, the number in front of x squared is 1, so a is 1. There's not an x, which means the number in front of x would have to be 0. And there's not another number after x squared, so it would also have to be 0. Another way of writing it would have been 1x squared plus 0x plus 0, and that would have made it more obvious what a, b, and c were. So we know what a, b, and c are. What we're going to do is we're just going to make a table of values. So we can graph anything that we ever want to in math using a table of values. Some of them will be harder or easier to do, but in this case what we want to do is we want to pick numbers for x and then plug them into this equation that we have so that we can get numbers for y. So if I don't have any idea what numbers to pick, I should pick numbers that are close to 0. So I'm going to pick -2, -1, 0, 1, and 2. And if you're wondering, well, why did she pick those particular numbers? For one thing, because I'm a math teacher, so I know it's a good idea. But just in general, if you don't have any clue what numbers to pick, these are good ones to start off with because of how close they are to 0. They'll at least give us an idea of if we picked good numbers or not. We have to try something, right? So might as well try these. What we want to do is take each of these numbers and plug them into y equals x squared. So we're going to do y equals -2 squared. When I square -2, it becomes +4. So when I plug -2 in, I get 4. Then I'll do the same thing for -1 and get 1 because -1 squared is 1. And then I'll do 0. 0 squared is 0. And then I'll do +1. +1 squared is also 1. And then I'll do 2. 2 squared is 4. What's really important here is understanding that when I plug in a negative into where an x is, that I put it in parentheses, and if there's anything in front of it, like if this had a 2 in front of my x squared, the 2 would go outside my parentheses. The squared goes outside the parentheses. Everything else in my equation goes outside of the parentheses other than the number that I'm plugging in. So what we've done here is we've now got points that we can plug in. Sorry, no, we have points that we can graph, sorry. So -2, 4 is right here. -1, 1 is right here. 0, 0, 1, 1, and 2, 4. Now when we connect these, we don't connect them with straight lines exactly. We want them to be curvy. If you are imagining, this kind of looks like a V. We want it to look actually a little bit more like a U. And we'll go past where our last dot is just a little bit and then finish it off with an arrow to show that it does keep going. Because if I plugged in 3, I would get 9. I guess I could have done that actually. It would fit on the graph. Too late now, I already drew it. But it keeps going up forever and ever, and if you notice, it goes up more steeply as it goes. Like we jumped from going to 1 to now going to 4, and then the next number would have been at 9. So you can see it's going up more steeply as it goes. So this is called a parabola. That's our fancy name for it. And then we're going to end up doing some other vocabulary related to this as well, to looking at it. Some of the other things that we want to point out about this are the bottom point of this is called the vertex. And the word vertex actually comes from a Latin word that means like, kind of signifies like the most of something. And so this is saying like the most, it's actually the minimum or the maximum of our graph, depending on which way our graph opens, whether it's up or down. So this opens up, so our vertex is the minimum of our graph. It's the very lowest point. Another vocabulary word that we have is the axis of symmetry. So the axis of symmetry has to do with, if I look at both sides of this graph, my numbers are similar. I've got 1 and 1 and 4 and 4. And so what's happening is the graph is symmetric along this vertical line right here. So we call that the axis of symmetry. Another thing that's important about this graph is that there is a direction that it opens. In this case, this graph opens up. The other types of graphs we might look at is, in Algebra 1 at least, is we'll look at some that open down as well. When you get farther in math, in Algebra 2 and pre-calculus, you'll also add to that parabolas that open left or right. But that makes things more complicated, so we save that for later on in math. Okay, here we'll write down some vocabulary just to have as future reference. The vertex is the top or bottom point on our graph. The axis of symmetry is the vertical line that splits the graph in half so that we have the same thing on both sides. It also, though, if you were writing it down, if you want the equation, it's x equals the x coordinate of the vertex. A parabola is pretty simply a U-shaped graph. That happens when x squared is the highest power in our equation. So in other words, having x cubed would not create a parabola, but having x squared as the biggest power does. The direction of opening is going to be up or down, and that is caused by the sign in front of x squared. And we'll see that in a later example, I think. If not, what's happening is that if I put a negative right here in front of my x squared, it makes it open down instead of opening up. So, yes, it does happen on a later example. Whew. Okay, so let's say we want to graph something more complicated than y equals x squared. What does that do? How does that change what we've got? So we're graphing y equals 2x squared plus 4x plus 3. We're going to plug in the same numbers as last time. And so this is going to take longer because there's more than one x to plug into. What's important is, at least at first, while we're doing this. We may be able to do it later on in our heads, but at first we want to write it down and make sure that we are doing the correct order of operations. We want to do -2 squared, which is 4, and then times it by the 2 in front. We don't want to do 2 times -2 first and then square it, although that gets very similar answers. In this particular case, that's not always the case. 4 times -2 is -8 plus 3. So we have 8 minus 8 plus 3, which is 3. When I plug in -2, I get 3. And then we want to plug in -1. And so we'd get a +1 when we square -1, and then we times that by 2. So 2 minus 4 plus 3, that's 5 minus 4, which is 1. And we've got 0 to plug in. The cool thing about 0 is this goes away, this goes away. It leaves us with whatever our last number is. Then we're going to plug in 1. And we get 1 times 2 is 2. 4 times 1 is 4. Plus 3. 6 plus 3 is 9. And then we plug in 2. We get 4 times 2 is 8, plus 8, plus 3, which is 19. So let's graph these points. -2, 3, -1, 1, 0, 3, 1, 9, and then the last one I have is off my graph. So this is different than what we saw last time. The vertex in this is right here at -1, 1. And so that means I could come back this other direction. I could say that means -3 must also be 9. And then I can finish drawing my graph. What's important here is that, or one of the important things, is our vertex was not at 0, 0. That only happens in certain cases. Typically, when we don't have this number right here that's by itself without an x, then we'll have a vertex that's at 0, 0. Otherwise, if we have a number like this, it'll be somewhere else. And so we got kind of lucky here that we picked good numbers still, because if this had a vertex over here, I may not have been able to figure that out without plugging in a whole bunch of extra numbers. So it would be nice if we knew what the vertex was at the beginning so that we could pick the numbers for our table of value based on that. Well, it turns out there is a formula for our vertex, and that formula is -b over 2a. If you're using the notes paper, it'd be great to put it up here where you wrote what a vertex was, just so that it's there in case you're looking back. So in this case, this is where we would label A, B, and C. -b would be negative what b is, which is 4, over 2 times a, which is 2. If I simplify that, that's -4 over 4, which is -1. And look, that is what our vertex was. So here are our steps for graphing a quadratic function. We're going to use the vertex formula, -b over 2a, to find the x-coordinate of the vertex. We're going to use that to pick our table of values. We put that number in the middle and pick numbers pick 2 numbers higher and 2 numbers lower than the vertex, and fill in the x column. Then once we know what the x column is, we can plug all those numbers into our original function to find the y values. Then we plot each point on our graph. And we connect the points into a smooth curve as opposed to something that looks like connect the dot puzzle or whatever. Before we graph another one, there is actually lots of information we can find without having to graph it. So these instructions say, without graphing the equation, find the following information. part A, we want to find the vertex. Part B, we want to find the direction of opening. And part C, we want to find the axis of symmetry. So we figure out what the vertex is based on what A, B, and C are. Our formula is negative B over 2A. So in this case, B is 2 and A is negative 1. So we're going to do negative 2 over negative 2 over 2 times A, which is negative 1. If we work that out, the negatives cancel, the 2's cancel, and we're left with 1. Now, if that's what the x-coordinate is, I don't need a whole table of values, I just need the y-coordinate that goes with it. So I plug in 1. And I get negative 1 plus 2 minus 5, which is negative 4. So my vertex is 1, negative 4. The direction it opens comes straight from the sign that's in front of x squared. A negative means that it opens down. A positive in front of x squared, or not having a sign in front of x squared, which means positive, means it opens up. The axis of symmetry is a vertical line, so it's x equals, and it's x equals whatever the x-coordinate of the vertex is. So if I graphed this, I could actually do an okay job of sketching this by just saying it starts at 1, negative 4, which is down here-ish. It opens down. And my axis of symmetry is this vertical line that's going through 1 on my vertex. So that's how that works. We didn't need to graph it though. That's just visually what we were being asked. So this next one is tough because we're going to get a fraction for our vertex. So please bear with me as we get through it. Because we want to do negative b over 2a. The negatives cancel. A 21 and a 3 can cancel and make 7. So this is 7 halves. The x-coordinate of our vertex is 7 halves. So we want to plug in 7 halves. And I'm telling you, this is awful because I've already done it once. We square 7 halves and get 49 over 4. Here, 21 times 7 is 147. So that's 147 over 2. 3 times 49 also is negative 147, if you'll believe it. And then to put these two things together, we need to get a common denominator. So this is going to be a 2 times by 2 on top and bottom. So that makes that 294 on top. Negative 147 plus 294 is 147 again. Whew. So I guess I need to go ahead and get a common denominator for this. 35 times 4 is 140. And so 147 minus 140 is 7. So we get 7/4. That was a whole lot of effort and work to get that our vertex is 7 halves, 7/4. My wish for you is that all of your problems work out to be a nicer vertex than that, although you know what? It sometimes does not happen, unfortunately. So what's important is I squared by squaring the top and bottom. When I multiplied, I put over 1. When I had to go to add, I had to use common denominators. So we want to make sure to remember to do all those things. This one also opens down because of this negative. And the axis of symmetry is x equals 7 halves. So that would be, if it asks us for that information without graphing, that's how we go about it. Now let's graph a couple more. We've got 2x squared plus 8x plus 10. Looking back at our steps, if you have them, the first one is use the vertex formula, negative b over 2a, to find the x-coordinate of the vertex. So we label a, b, and c. We want to do negative 8 over 2 times 2. Negative 8 over 4 is what that becomes, which is just negative 2. So we haven't done this yet. We want to pick our table of values based on this negative 2. Negative 2 goes in the middle. We need to pick two things that are more negative, or to the left of negative 2 on the number line, and two numbers to the right on the number line. And we want them to be the closest numbers also, because numbers can get really big really fast whenever we're doing parabolas. So the closer it is to our vertex, the better off we will be. So let's start plugging in. And again, if you can do some of this in your head, that will make it quite a bit easier. Like this is 16 times 2 is 32, minus 32 plus 10, so that's 10. Plug in negative 3. And get 9 times 2 is 18, so minus 24 plus 10, that will be 4. It doesn't matter which order you plug the numbers in, just so long as you plug them in. This is 4 times 2 is 8, minus 16 plus 10, negative 8 plus 10 is 2. And then we'll notice something interesting if we haven't already. Maybe you already thought this would be the case. This is 2 minus 8 plus 10, which is 4. Notice that my two numbers closest to the vertex got the same y value, and then whenever I plug in 0, the same thing happens. I get 10, which is what the top number was. And so if the middle is the vertex, if the numbers that we pick are equal distance from negative 2, like negative 3 and negative 1 are both 1 away from negative 2, then these two numbers should be the same. If negative 4 and 0 are both the same distance from negative 2, these should be the same numbers. That's the axis of symmetry at work. So now we just need to graph negative 4 comma 10, negative 3 comma 4, negative 2 comma 2, and then back up. And we connect this in a smooth curve. I'm not super great at doing that on the computer. I'm personally better on paper. So there we go. One more example, and this is where if you think you know what's going on, you should try it for yourself and pause the video so that you can see if you've actually got it. But if you still need more help, then just keep watching the video. We've got a, b, and c. So negative 6 over 2 times negative 3. Remember, our formula is negative b over 2a. And this is a, b, and c. We don't plug the x squared and the x in with a and b because a and b are just the numbers in front of those. So this is negative 6 over negative 6, which is 1. So for our table of values, 1 is going to go in the middle. We want to pick things that are to the left on the number line and two things that are on the right. We plug each of these in. This is 1 times negative 3 is negative 3, minus 6, minus 7, negative 9 minus 7 is negative 16. Well, that's not going to fit on our graph. How unfortunate. When I plug in 0 to these, I get negative 7. Anytime I plug in 0, it's just whatever the last number is. I plug in 1. And get negative 3 plus 6 minus 7, which is negative 4. If we're confident about these top two numbers, because of our axis of symmetry, we can fill in the bottom two as well. If we're not confident, then we'd want to go ahead and plug them in so that we can verify that we got the right answers. I can't fit the bottom and top points in the graph, and that is okay. I don't know why I just stuck that point there. That is not where that goes. 0, negative 7 is one of my points. 1, negative 4 is one of my points. 2, negative 7 is one of my points. So this opens down. and is a fairly skinny looking parabola. And that is all there is to it. We want to follow those steps. We want to find the vertex, use that for our table of values, and then we want to plot those points on our graph. So that is how you graph quadratic equations.